Hey guys, today we're going to be looking at lesson 3, which is multiplying radicals. Multiplying radicals look something like this. You might have one radical times another. Very simple. You basically have two options for something like this. If you want, you could just multiply them. Square root of 8 times the square root of 12 is the square root of 96, but then you have to simplify the radical. So you have to try to find a perfect square that goes into 96. So in your mind, you're going through the list of 4, 9, 16, 25, etc., etc., etc. So 16 goes into 96. And that's going to be times 6. And then you take the square root of 16, which is 4, so it's just 4 radical 6. If you want, you could simplify the radical first in the beginning if possible. So you could have also simplified the square root of 8, which is the square root of 4 times 2, which is 2 radical 2, and multiplied that by the simplified version of the square root of 12, which is the square root of 4 times 3, so that's going to be 2 radical 3. And if you multiply those, the rational numbers on the outside multiply with each other. 2 times 2 is 4. And the irrational numbers on the inside multiply with each other. The square root of 2 times the square root of 3 is the square root of 6. And you end up with the same exact result. So you always have that option. And so basically outside numbers multiply with outside numbers because they are rational. And the numbers inside the square root multiply with each other because they are irrational. Okay, here's another example. Example 2. If you have 4 radical 6 times 7 radical 2, in this example, you don't have the option of simplifying first. So you have to multiply the rational outsides. 4 times 7 is 28, times the irrational inside numbers. The square root of 6 times the square root of 2 is the square root of 12. And then in this case, you have to recognize at the end that the square root of 12 contains a perfect square as one of its factors. 4 goes into it. So that breaks down into 4 times 3. The square root of 4 is 2. That 2 multiplies by the 28 that was on the outside. So that's going to be 56 radical 3. Okay. Whenever you multiply a square root by itself, so example 3. Whenever you multiply a square root by itself, like the square root of 3 times the square root of 3, your result is going to be that number, but the rational version of that number. The reason is, if you think about the square root of 3 times the square root of 3, the little in-between step that occurs is it's the square root of 9. And 9 is a perfect square. The square root of 9 is just regular rational 3. So any square root, like if I said the square root of 1,000 times the square root of 1,000, the result would just be 1,000. Rational 1,000, not the square root of it, but just 1,000. Okay, so whenever you see a number being raised to the second power, an irrational number being raised to the second power, like the square root of 5 squared, the result, you can sort of skip all that work and just say, well, the answer is 5. Because it's going to be the square root of 25, which is 5. And remember that if there's a number being multiplied on the outside, like if it was 5 times the square root of 6 squared, right, that's 5 times the square root of 6 times itself. 5 radical 6 times 5 radical 6. Well, the 5 squared, 5 times 5 is 25. And square root of 6 squared is 6. So this would be 25 times 6, which is 150. And lastly, we're going to look at some distributive property problems, which are pretty simple and straightforward also. Example 4. If I gave you the square root of 3 being multiplied into 7 minus 2 radical 6, you're just going to use the distributive property. But remember, like 7 is just a rational 7, but the square root of 3 is irrational. So they can't actually multiply with each other. You would write this as 7 radical 3. And then the square root of 3 times negative 2 square root of 6 you're going to multiply the square root of 3 times the square root of 6, and then the 2 will be on the outside. So it'll be negative 2 times the square root of 18. And remember, you're not finished until you try to simplify. So I see that the square root of 18 contains a perfect square. It contains 9. So that's really square root of 9 times 2. So the 3 comes out. My final answer is 7 radical 3 minus 6 radical 2. And that's a binomial answer. You can't combine those again because they don't have the same number under the radical. And then our last example for today will be similar to this, example 5. Um, 5 radical 2 times 6 plus the square root of 8. So you could try to pause me now maybe and try this one on your own. I'm going to distribute. The 6 multiplies just with the 5, so this will be 30 radical 2 plus, and then the square root of 2 is irrational, multiplies with the irrational square root of 8. So this will be 5, because it's really a 1 in here, so 5 times 1 is 5, times the square root of 16. Now, the square root of 16 you have to recognize is a perfect square. So the square root of 16 is 4, just a rational 4. So my final answer is 30 radical 2 plus 5 times 4 is 20. And that cannot be simplified because you can't combine the square root of 2 with the 20. They're unlike terms. Okay, so try that today for homework. Have a good day, guys.